Commonly used dimensions. There are three dimensions that are commonly used: length, capital L, mass, capital M, and time, capital T. So in the upcoming examples, you will see that these three dimensions are commonly used. Now discussing some examples of dimensions. Number one, velocity. As v is equals to d upon t, as we have discussed in previous slide as well. So how can you write this dimension? You have to write this dimension as lt minus 1. Now there is written m0. m0 means there is no existence of mass in the formula of velocity. Now next thing is acceleration. For acceleration, you know that the formula is velocity per unit time. So velocity has the formula of lt minus 1 or dimension, and for time it is again t minus 1. So the dimension will become lt minus 2. Again m0 means that there is no physical appearance of this mass. Okay. Next thing is force. Force has the formula of ma. So m means mass having the dimensions of capital M. A has the formula of velocity per unit time. From this situation, it will become lt minus 2. Now this m has the power of 1. Now it has its physical appearance in the formula of force, whereas for m0 means there is no physical appearance of this this quantity in that given equation or in that given formula. Now for energy, you can calculate the formula of energy from kinetic energy. Kinetic energy has the formula of half mv square, as well as you can calculate the formula or dimension of energy from potential energy, as potential energy has the formula of mgh. Same, you can calculate the dimensions of energy from work. Work has the formula of force into displacement, and by calculating all these dimensions you will come to know that the dimensions are same. So what is the meaning of this thing? That one unit has one physical appearance, so one dimension. Okay, so this is basically the dimensions of unit joules, because joule is the unit of energy. So what will be the formula is ml square t minus 2. And if we calculate this energy from work done, so work done has the formula of force into displacement. So force has the dimensions of mlt minus 2, whereas again displacement has the unit of length or dimension of length. So collectively it can be written as ml square t minus 2. Now to calculate the speed of an object is distance covered by it in specific time. So formula is distance upon time. Dimension of distance is L, dimension of time is T. So dimension of speed will become L upon T. So denominator will come T minus 1. So the rule will apply that you have to write all the dimensions in single bracket. So this is LT minus 1. For the convenience and for the better appearance, you have to write it like m naught LT minus 1. This is in the subscript. Now for second example, its density of a body is defined as mass per unit volume. So density is mass per unit volume, and mass has the dimensions of capital M, whereas volume has dimensions of L cube, as we have discussed and see in the previous slide. So this will become ml3 or L cube. Now this is written as ml minus 3 or ml minus 3 t0, because t0 means that there is no any appearance of that time factor. Now for next thing, this is force. Force is equals to mass into acceleration. Now acceleration has the formula of velocity upon time. Now write the dimensions. This is length upon time into time. So this is mass into length into times minus 2, as this factor is coming in the numerator. So t minus 2. So you can write m l t minus 2. To calculate the dimensions of energy, I am writing here the three formulas of energy, like potential energy, kinetic energy and work, and they have the same unit of joules. So you can calculate the dimensions from any of the three formulas. I am solving it from force into displacement by writing the dimensions of this force, and displacement has a dimension of length because of its unit. So it will become ml square t minus 2. This is the dimension table, and these are some dimensions. Now you have to calculate each dimension one by one, like the dimension of work done, pressure, power, in your copies, and you have to show it to me right now, so that if you have any confusion we will discuss it.